In this problem, a pelican enters the water with a speed of 15 meters per second at an angle of 20 degrees from a vertical line drawn perpendicular to the surface. Current pelican theory predicts that as they dive through the water, they experience a drag force proportional to their speed q. To find the initial position of the pelican is set to the vector of 0, 0, 0, and we are then asked to add in the initial velocity of the pelican as it enters the water. We can use this by finding the x component of its velocity, doing 15 times the cosine of 20, and then we can find the vertical part of its velocity by doing 15 times the sine of 20. And then it is not moving in the z direction, so that this is set to 0. We are then given our constants t, delta t, g, and b that we can use later on in the code. Then, while t is less than 1, we must add the necessary code to update the position of the pelican. We must first set j hat as a vector of 0, 1, 0, which we will later be able to use for gravity, which only occurs in the y direction. V direction is then a constant of the unit vector of the pelican's velocity, which we can find by dividing the pelican's velocity by the magnitude of its velocity. F gravity is the negative of the mass of the pelican times gravity times j hat, so that it is shown that gravity only moves in the y direction. F drag is then set to negative b times the pelican velocities cubed times the unit vector, and F net is then equal to gravity plus drag force. We can then find the velocity of the pelican by adding its current velocity to F net divided by the pelican's mass and multiplied by delta t, which we can derive from Newton's second law. And we can then find the position of the pelican by adding its current position to its velocity times delta t.